Okay, so we're going to start talking now about momentum, and momentum is this concept that we use to describe the reason why we would rather get hit by a little plastic car rolling down the driveway than this big semi-truck rolling on the freeway. Okay, clearly you'd rather get hit by a little plastic car than this giant big red truck. And we can quantify that reason using this concept called momentum. Okay, so objects with a lot of mass have a lot of momentum, but we'd also rather get hit by, say, this truck here moving 1 mile per hour than maybe moving 100 miles per hour. And so it also has a factor here of velocity. Okay, and so momentum just comes down to basically an object's mass times its velocity. Okay, our unit for momentum is kilogram meters per second, and we use the letter P for like a symbol for momentum, and we calculate it just by multiplying the mass and the velocity of an object. So here's an example. We have a dog. It's got a mass of 30 kilograms. It's running at a speed of 6 meters per second. So go ahead and in your notes calculate the momentum of the dog. You should have found that the dog has a momentum, if you multiply 30 times 6, of 180 kilogram meters per second. So a bus might have a really large momentum, even if it's moving slowly because of the large mass that it has. But in order for an object to have momentum, it needs to be moving. If something has zero velocity, it has no momentum. Also, it has to have mass in order to have momentum. If an object has no mass, then it has no momentum. Okay, so now I want you to find the momentum of a sprinter with a mass of 50 kilograms who's running at a speed of 10 meters per second. You should have gotten that she has a momentum of 500 kilogram meters per second. And then here we have this wolf. It has a momentum of 480 kilogram meters per second, and it's running at a speed of 8 meters per second. Go ahead and find the mass of the wolf. You should have got 60 kilograms. Okay, using your momentum equation, P equals mv, 480 equals m times 8, and you divide by 8 to solve for mass. If you were to double the velocity of a car, how much would its momentum change? It would change by a factor of 2. I want to talk about making graphs to illustrate momentum. Okay, so let's say that we have a just a car, and it's rolling along. Say it has a mass of 500 kilograms and a velocity of 2 meters per second. Okay, let's say that we also have a let's say this is a bullet. Okay, and it's flying through the air. Let's say that it has a velocity of let's say 1,000 meters per second. This is kind of a silly question because we're going to say it has a mass of 1 kilogram, which is a lot for a bullet. But I want to find the momentum of each of these things. Okay, and when I like to find momentum, or when I find momentum, I like to make a chart here, and this is what I want you to get used to. And one axis represents mass, and one axis represents velocity. Okay, and so this car has a mass of 500 kilograms. So I have this really wide stretch of the graph, okay? And it's got a velocity of 2 meters per second. Okay? And so here we have the bar representing the momentum of the car, and we can find the car's momentum by finding the area of this bar. So 500 times 2 is going to give us 1,000 kilogram meters per second. So that represents the momentum of that car. Okay, meanwhile, with the bullet, we can find momentum too using our chart. Okay, the bullet has a mass of 1 kilogram, so much narrower. Okay, but it's going to be very, very tall because it has a velocity of 1,000. Okay, and 1 times 1,000, m times v, is going to give us again 1,000 kilogram meters per second. So both the bullet and the car in this case would have the same momentum.